Hello and welcome to the next video in the series introducing HyperFlow AI. In this video, we will explore building and running flow graphs. You build and refine flow graphs in the Flow Graph Editor within the main HyperFlow Integrated Development Environment, or IDE. This can be accessed by selecting Editor in the main UI Mode panel here. Flow graphs you've already created or installed appear in the Flow Graphs tab in the directory pane on the left. Selecting one will load it into the editor. You can create new flow graphs in several ways: by duplicating an existing flow, or cloning one of the template flow graphs here in the Templates tab, or simply by creating a new one from scratch. In all cases, a detail dialog pops up, letting you name and describe your flow graph, give it tags to place it in the flow graph directory on the left, and make it public or private. You can edit these details at any time by selecting Edit Details in the Flow Graphs drop-down menu up here. Flow graphs are made of nodes connected by process flow lines and data flow lines. You select the nodes you want from the Node tab in the directory pane, within which they are organized in functional groups. There are around 40 node types in the current release of HyperFlow, each performing a particular task useful for some aspect or other of building an AI application or workflow. You add them to a flow graph by dragging them onto the flow graph surface. I'll select first the user input node, which accepts an input prompt from the user, and then an LLM call node, which can send the user's prompt to an LLM model and receive its generated response. The process flow lines, which are purple, connect up nodes in the order they should perform their tasks. So here I'll set the input to run first and the LLM call to run next. The LLM call node needs to know what the user has input, and so we connect the user prompt output here to the user prompt input on the LLM call node using a blue data flow connection. You can see that the user input node has other outputs, and the LLM call node has many other inputs. These relate to the varying capabilities of each node, and we'll explore them all in later videos. They are also documented in the nodes reference section of the beta documentation. But for now, these connections are all we need to get a simple chatbot going. As it stands, this will ask for one input from the user and hand it off to the call node to send it to an LLM and get its response, and then stop. A one-shot chatbot. So let's wire the process flow exit connector here back to the enter connector of the user input node, creating a looping chatbot that enables a sequence of interactions between the user and the LLM. HyperFlow lets you wire up directional graphs that have cycles in them, so-called directed cyclic graphs, and these are essential for building advanced AI applications and workflows. Before we run this flow graph, let's quickly go through some of the basics of working with flow graphs in the editor. If you make a mistake in wiring, just grab the end of the wire and either drop it to delete the wire or drag it to the connector you intended. Let me fix this guy up. You can reposition nodes in the graph at any time just by pressing and dragging. You can also drag out a selection rectangle around a group of nodes and reposition them as one. You delete a node by right-clicking on it to bring up its context menu and selecting Delete. You can see several other useful actions in the context menu, some of them pretty obvious. Others we'll explore in this and other videos. You can undo or redo actions with the buttons up here, or by typing Command or Control Z. Let's undo that delete. And you can copy and paste collections of nodes, making it easy to borrow parts of flows from one flow graph and use them in another. Now, the nodes in HyperFlow are all very powerful and flexible, supporting many different options, all related to their basic function. You control these options by setting the node's parameters, also called hyperparameters, to differentiate them from the parameters that make up an AI model's neural network. You can see a node's parameters just by clicking on it, bringing up its parameter panel here on the right. To make it easy to get going with HyperFlow, most nodes have useful preset values for many of their parameters, and we'll stick with those for now. In the case of the user input node, it defaults to asking for a simple text prompt, but can be set to accept file uploads as well. And the call LLM node defaults to a regular chat-based call, but can be set to generate other media as well. Now, it does want us to select the LLM service that it will talk to, as indicated by this red outline around the LLM service selector. Clicking on this brings up the set of LLM services that HyperFlow currently has direct access to, all the main commercial services, and an Olama server built right into HyperFlow, offering all the main open source models. We can either select a service now before we run the flow graph, or wait until we run it and HyperFlow will pause when it gets to this node and ask us to make a selection then. This option is actually a very important and unique aspect of HyperFlow as a development tool, helping AI developers efficiently test and tune and perfect their applications. It gives the developer a way to set up a test run, presetting many of the parameter options, leaving others to be adjusted and tweaked while the flow graph is running, an ideal way to optimize the most important parameters in a flow graph. For now, let's pick the OpenAI service. HyperFlow connects to OpenAI to get a list of its currently available models. Quite a few, but let's leave model selection until runtime in case we want to try different models as we run it. The call LLM node is one of the most powerful in HyperFlow and has many parameters, but we've selected useful default values and collapsed many of them in the UI to keep things simple. As you gain experience and want to explore the node's full capabilities, you can dig into all the node's parameters. The final thing we want to do, given that this is a looping chatbot allowing back and forth conversations, is to let the LLM see its side of the conversation by looping its generated responses back to its prior responses input, like this. LLMs generally do not have long-term memory, and so the whole conversation history needs to be sent to the LLM on each call. Okay, let's run the thing. We'll do this firstly in developer mode by clicking the run button up here. It's called developer mode because it is giving the developer a very detailed and close look at how the flow graph is performing. And it's not like a conventional chatbot at all, and intentionally so. Firstly, the flow graph is zoomed and positioned to show us the currently running node, so we can easily see the flow graph's progress. At the same time, two panels open up on the right. The closest is the same parameter panel we saw while working in the editor, letting us provide input as a test user or make parameter selections that we decided to leave until runtime. You can see we have paused on the user input node, waiting for user input. The panel on the right is a run session log, showing us a detailed history of this flow graph's run, currently showing only that we are at step 1, waiting for an OK in the parameter settings panel. So let's type a prompt, say, why are there 7 colors in the rainbow? And hit OK. The flow graph moves along to the call LLM node, asking us now to select an OpenAI model, just as we had intended that it should. I'll pick one, say GPT-4o Mini, and press OK. The prompt has been built and sent off to GPT-4o Mini, and the responses come back already, displayed in the session log on the right. And the flow graph has looped around back to the user input node, giving the user a chance to continue the conversation. Before we do, let's look at the session log. All the details of the run so far are available in the log. Some have been collapsed to make it less cluttered, but you can open any of them up for a deeper inspection. For example, all of the parameter settings for the call LLM node in step 2. We can also see other useful information, such as the prompt that was sent to the LLM, where the proximate token counts, and of course, the generated LLM response. And down here, metadata on that call, where the elapsed time, tokens in and out, and so on. So let's continue the conversation. Say, why is it in the shape of an arc? Here, I'm referring back to earlier parts of the conversation, so it's necessary to ensure the combined prompt as that conversation history so that the LLM knows what I am referring to. You can see that the LLM has correctly inferred I'm asking about rainbows because the call LLM node has assembled a composite prompt, which you can see here, containing the conversation history, the first user query, the first LLM response, the second user query, and so on. As we continue running the flow graph, the log will grow, full of very helpful information for the developer. Again, this is developer mode, and so we want to see and understand everything that's going on in our flow graph. There are run modes that open simulated chatbots so we can see what an end user might see, and we'll explore those in later videos. We can drop out of the runner at any time by simply selecting Editor in the Mode buttons up here and continue editing and tuning our flow graph, adjusting parameters by clicking on nodes to bring up the parameter panels, and then running it again by clicking Run. Note that the run logs are stored and can be recalled and re-examined at any time by selecting the Run History item in the Run button drop-down. Okay, we've covered all the basics of building and running flow graphs in HyperFlow, certainly enough to get you going. There is a lot more to discover, and we'll dig into things like flow graph single stepping and breakpoints, locking and unlocking parameters, wireable parameters, history access in data flows, and much more in later videos in this series, so be sure to check them out. But for now, we'll sign off and let you have some fun building your own flows.